Okay, so for example, letter B, we have dy dx equals the sine of 5x minus cosine 3y with initial condition of y of pi equals to 0. So number one, let's check for existence. So number one, letter I rather, existence. So is dy dx, well actually, let's state the function f of xy first. F of xy equals sine 5x minus cosine 3y. All right? So for condition I is dy dx at pi comma 0. Is it defined? Well, for x we substitute pi and for y we substitute 0. So sine of 5 pi minus cosine of 3 times 0. Well, what's sine of pi? Well, sine of 5 pi, it's actually the same as sine pi. All right, it's how do we call those? And it's coterminal to pi, right? So that's going to be 0. Okay, so that equals to 0. And in this case, that's a negative 1, isn't it? So negative 1. Well, it's defined. This means a solution exists. All right, now the question here is that solution unique? Okay, is that solution unique? So for part double I, well, we need to take the partial derivative of this function with respect y, not x, with respect y. Well, this term is going to go to 0 because that's a function that depends only on x. So if we're differentiating with respect to y, anything containing x is constant. So the derivative of a constant, and in this case, this sine of 5x is an additive constant. So we just need to differentiate the 3y. So that's going to be, okay, careful because the derivative of cosine is negative. Times the negative in the front becomes positive sine of itself 3y. And by a mini chain rule, don't forget to multiply by 3. All right? So what's next? Evaluate this partial derivative with respect y at the point pi comma 0. Okay? Well, so whenever you see the letter x, well, actually there's no x. So we will only substitute the y equals 0. That's 3 sine. 3 times 0, which is, but what's sine of 0? Isn't that 0? Well, this is a defined value, right? So this means solution is unique. This means the solution is unique, yes.
If you were to get a solution that's not like this, would you just skip the second part?
We just skip this exactly because, I mean, no solution, so yeah, there's no point to check second. That's a good question. So the minute no solution, it's undefined, no solution exists, that means just skip part B, all right? Part 2 of the theorem. I mean, compare and contrast the two exercises here. Well, for the first one, a solution existed. However, when it came to finding the partial derivative with respect y, we got an undefined value. Unlike the second example, letter B, we have a solution that in this is unique. Okay, the next exercise might be a little tricky. So, okay, let's see. So, dy dx equals the square root of x times y. Okay? So here is the thing. I would like, first of all, to write dy dx equals, using properties of radicals, I'm going to use the product of two radicals. That's the square root of x times the square root of y. Okay? Because then we're going to take the partial derivative of it. Okay? So this will be equal to x to the 1/2, y to the 1/2. Okay? So let's see, letter I, if dy dx is defined at 0. Okay, if it's defined at 0 to the 1/2, y to the, or rather 5. Whoops. to the 1/2. Okay, that's at 0, 5. Okay. Okay, this is equal to 0, right? So you may think about this one, oh, okay, well, this is defined, all right? However, we have a problem. So it's not just being defined. It's not just about having the function being defined, but also to be continuous at that point. Okay? So that's what it says in the denominator. If f is continuous, okay, now we have a problem here. Consider the graph of the radical function, okay, at 0, okay, at the origin. Do you guys agree that the function it's not continuous at the origin? It is defined at the origin, but it is not continuous because coming from the left, okay, coming from the left, of course, I mean we can arrive to the origin from the left. However, do you guys agree that there's nothing from the right of the graph? All right, so that tells us the function is not continuous. So yes, defined, but not continuous, because there's nothing from the left. And that's a tricky one. That's one of those that you would like to go like way like, yes, it's defined, but it's not continuous from both sides, only from the right. And the definition of continuity is that the limit from the right equals the limit from the left. However, what do we have for the limit from the right? Well, 0. But the limit from the left does not exist because there's no graph from the left. So one of those tricky ones you might want to look for. Okay, so there's one more. Okay, one more exercise, and this is more like the type of problems that you will see on the homework. So, okay, so let's consider the initial value problem we have right here. That is y prime equals to y of t naught equals to y naught. So in this case, the independent variable is t. That's the input variable, and the output variable, the dependent variable, is y. All right. So they're asking us for, okay, existence and uniqueness is warranted for all points except which ones? Okay, so number one, let's define a function. Okay, instead of defining a function of x and y, we're going to define a function of t and y, not of x and y. I mean, it doesn't matter what variables we use as long as we give the correct dependent independent variable for what they are. All right? Okay, so that's our function cube root of 5y minus 8. And that's divided by 4t squared minus 7. All right? All right. So, I mean, essentially what we're going to do here is find the domain of the function and find the domain of the derivative with respect to y. That's how we will determine for which values do we have existence and uniqueness. Well, so it seems like this function is defined for all values of y and all values of t, except some values of t, those that make the denominator 0, right? So, okay, so existence for t except 4t squared minus 7 equals to 0. Solve the equation. T squared equals to 7 over 4. And how about plus t equals plus or minus the square root of 7 over 4. And in this case, we could use the quotient rule for radicals. The square root of 7, it's just a square root of 7. That's fine, just leave it. Plus or minus root of 7. But in the denominator, that's simply 2. Okay? So, if we substitute either plus or minus root of 7 over 2, that's going to give us an undefined value in the for the function. So we wouldn't have a solution to the differential equation for these values. However, for the remaining values, for which ones do we guarantee a unique solution? Well, so that's part I, part double I. Well, we need to find the partial of f with respect. Why? Well, in this case, I would like to rewrite 5y minus 8 to the 1/3. Everything divided by 4t squared minus 7. All right. So, okay, well, in this case, do we really need the quotient rule to differentiate this with respect to y? Not really, because the denominator, 4t squared minus 7, well, that's just a constant with respect t, all right? So this will be, this is the multiple constant, 1 over 4 t squared minus 7 times the derivative of the numerator, which is 1/3, times 5y minus 8 to the negative 1/3. All right? Okay. So let's see. Well, we need to rewrite all this. Okay, that is, so that's 1 over big fraction. I'm going to write the 3 times 4t squared minus 7 and 5y minus 8 to the 1. Oh, I didn't subtract, right? Yeah. So minus 2/3, right? Minus 2/3 and positive 2/3 right here, all right? So in this case, we need to check what values, jointly t's and y. Yes?
Do you need a 5?
Oh, yes, I need a 5. Yeah, by mini chain rule, right? Yes, this 5. Thank you. 5. All right? Thank you. Okay. So, okay. So now we need to look jointly what values of t and y make this undefined. And if we exclude these values, this differential equation will have uniqueness. Will have existence and uniqueness of a solution except for those values. Well, for these ones, didn't we get already that t equals plus or minus root of 7 over 2? But also we have another potential 0, that is where 5y minus 8 equals to 0. That is 5y equals to 8 or y equals to 8 over 5. All right? So as long as we don't go through those points, we're good, right? Otherwise, we will have multiple solutions, right? 2 solutions, right? We wouldn't have any uniqueness in the solutions. All right? And it seems like that's the last example in the notes, right?